Learning with Dewey and Luke's Trigonometry. Question 1. What is trigonometry and how does it work? Trigonometry is a branch of mathematics that studies triangles and their relationship between their sides and the angles between these sides.
Trigonometry has three different formulas: sine, cosine, and tangent. Sine involves the opposite side of the triangle and the hypotenuse. Cosine involves the adjacent and the hypotenuse, and tangent involves the opposite and the adjacent. To learn these, you can say so, ka, toa. The hypotenuse is always the longest side of the triangle. The opposite is always on the opposite side of the angle, and the adjacent is in the side that remains.
An example for sine, which involves opposite and hypotenuse, we are going to find the value of x in this triangle. X in this case is the opposite, so we solve sin 47 in the calculator equals 0.731. Then we multiply sin 47 times 15, which is 10.970. This is the value of x. For an example of cos, which involves adjacent and hypotenuse, adjacent over hypotenuse, we're going to find the value of x in this triangle. So we first solve cos 64, which is 0.438. With this value, we'll multiply it by 18, which is the hypotenuse of the triangle. So it would be 18 times 0.438 equals 7.884. This is the value of x.
Question 2. Show how at least two other topics we have studied this year in maths are involved in trigonometry.
One of the topics we've seen this year that involve trigonometry is solving equations, because when we have a trigonometric problem where we are looking for a missing variable like angles, missing sides, etc., we need to solve the equations from the problem that come from the problem correctly. With this problem, we can find the height of this building using the method TOA. Tan 60 equals x over 25. This means tangent equals opposite over adjacent. So what we have to do is solve the equation, which is x equals tan 60 times 25, which is 43.301 meters. That's how you know the height of this building. Another topic we saw that involved trigonometry was Pythagoras, because when we are looking for a trigonometric relationship of a right triangle's angle and we don't have the lengths of the three sides and just have two sides, we use Pythagoras to find the missing side. So then we are able to calculate the trigonometric relationship that we need. Question 3. How tall is the Omega building?
These are the materials that we used: an iPhone clinometer, a clinometer, a meter measurer, and a tape measure. So we needed to find how tall was the Omega building. So what we did was, first, measure how tall was G1. She measured 1.63 meters. Then, with the iPhone clinometer and the clinometer, we found out the angle of elevation of the building, which gave us 56. Then, with the meter measure and the tape measure, we measure how far was the Omega block from G1. The answer was 9.8 meters. Now what we need to do are the calculations. First, we use the law of sines. We started by finding the missing angles. So we did 180 minus 90 minus 56, which gave us 34 degrees. After having the missing angle, we did sin capital A over A equals sin capital C over C, which is sin 34 over 9.8 equals sin 56 over C. For doing this, we needed to cross multiply. So it will be sin 34 times c equals sin 56 times 9.8. We did sin 56 times 9.8, which gave us 8.124. Then we divided that number by sin 34, which gave us 14.529. But 14.529 wasn't our final answer. We needed to add the height of G1, which was 1.63. Once we added that, the answer was 16.159 meters, which is the length of the omega block.
We found another method to find the length of the omega building. It was using TOA. Tangent equals opposite over adjacent. So we did tan 56 equals x, which is the opposite in the triangle, and 9.8, which is hypotenuse. So we did cross multiply. X equals tan 56 times 9.8. Tan 56 is equal to 1.483. So then we multiplied it by 9.8. This gave us 14.529. But we couldn't leave the answer alone. We had to add my height, which was 1.63 meters. So we did 1.63 meters plus 14.529 meters equals 16.159 meters. As you can see, for both methods we used, we had the same answer, which was 16.159 meters. Question 4. Explain the degree of accuracy in your answer of question 3. Explain whether you think your answer makes sense.
Both of our methods gave us the same answer, which was 16.159 meters, and that was using law of sines and TOA. Tangent equals opposite over adjacent. But it's not very common that the measurement of a building has a decimal, so we decided to ask our classmates for the results, and the results were very similar to ours. 15 point something, 16, or 16 point something. Are there any ways to improve our results? For the next time, we could ask for the building plans. I think that idea is the most accurate, since an architect is the one that decides how tall the building is going to be. Also, a very good way to improve the accuracy is by counting the bricks, and then with a ruler measure the length of one brick, and then multiply that answer by the amount of bricks you counted. Question 5. Explain one other way trigonometry is used in the real world. You must use a specific example. We choose a navigator. Navigators use trigonometry to determine locations, to chart paths, or to determine how far a ship or a plane is away from land.
This isn't easy, I just need to say